Hey class, we've finally reached the end of the chapter, so today we're going to be working on just writing quadratic equations. So we're going to use three different methods or three different examples to show one for each form that we've talked about this chapter, and then I'm going to show you guys how to use Desmos, and then we can go from there. So we're going to go ahead and start off by just jumping into an example where I want you to take some information from a graph and write the equation in vertex form. And we kind of practiced this the other day, but let's start off with our basic example. So draw your graph in. I'm going to give you a couple things of this for this parabola. So I'm going to give you the points at 1, -2. So this is going to be your vertex. And then I'm going to give you a point 3, 2. So 1, 2, 3. That'll be a random point, and then the parabola goes through this. Okay, so maybe I draw another point over here at -1, 2. Okay, so we've got this nice parabola drawn in, and I want you to write an equation for this graph. So remember, it says vertex form, which you have to know that form. So first, vertex form is y equals a times x minus h squared plus k. So remember, h and k come from the vertex, and then a we have to find. So if we know our vertex right away, so we said this was at 1, -2, all we have to do is plug this into h and k. So when I do that, I'm going to have y equals a, and then x, and then minus my x value here, so -1, okay, all squared, and then plus the k, which in this case k is -2, so it'll be -2. So this just came from the vertex. Done. Okay, but we don't know a yet, so we have to find it. And this is where having an extra point is going to be very handy. So if I know another point on my parabola, then all I have to do is plug this in for x and y and solve for a. So I'm going to plug in, wherever I see an x, I'm going to plug in a 3. So I'm going to have 3 minus 1 squared, then -2. I don't know a yet, and then I know that my y value for this point was 2, so I'm going to plug in a 2 there. And now it's just a matter of solving. So I'm going to have 2 equals a times 3 minus 1 is 2 squared, and -2. Then I do PEMDAS, so parentheses, then exponents. So I have 2 equals 2 squared is 4, so I get 4a minus 2. And now I can just solve for a. So I add 2 to the other side. Those go away. And I get 4 equals 4a. And then, of course, dividing both sides by 4, we get that a is equal to 1. So we'd be done. Okay, so our final equation for this, so final answer would be y equals, we just said a was 1, and then we'd have x minus 1 squared minus 2. So this is our entire equation in its vertex form. So there was basically 2 steps to this. I plugged in the vertex. That was step 1. So I'll put vertex here. And then step 2 was solve for a. Okay, that's all you need to know for vertex form. Every vertex is going to change, every point's going to be different, but the process is exactly the same. You plug in the numbers, and then you solve, and then you rewrite your equation at the end. Now the next example is if I give you something that's in intercept form. So in intercept form, remember our form looks like this. Y is equal to a, and then we have x minus p times x minus q. And remember, p and q, those are just numbers, same with a. So let's say I give you this graph. An x-intercept at -1 and an x-intercept at 4. And then I give you another point at 3, 2. So it's some graph that looks like this. Okay, not exact, but it's a rough estimate. So looking at this picture, what are the x-intercepts? Well, we know that one x-intercept is at -1, and the other x-intercept is at +4. Okay, and we have a point at 3, 2. Okay, so we've got a random point there. So I'm just going to plug in what I know. So remember, p and q are my x-intercepts. So I'm going to have y equals a times x minus my -1, and then times x minus my 4. And remember, 2 negatives make a positive. So now we just have to simplify. So y equals a times x plus 1 and then x minus 4, but we still don't know a. So just like the last example, we have to use our point here to solve for a. So I'm going to plug in my y's and my x's. So I know my y was 2, and then I have a times, and my x's are 3. So 3 plus 1 and 3 minus 4. And now I just simplify. So I get 2 equals a times 4, and 3 minus 4 is negative 1. So we get 2 equals a times negative 4. I just multiply these together, and then of course I can divide both sides by negative 4, and here I get that a is equal to negative 1/2. Now remember, a is not your final answer, the equation is your answer, so I just have to plug the a back in. So my final answer is going to be y equals negative 1/2, and then keep everything else in its vertex form. So the x plus 1 and the x minus 4. If I want it in intercept form, you do not have to FOIL anything. Okay, so don't multiply it all out. This is its final answer because it's in its factored form. Just like in the vertex form, we leave it in that form. Okay, so you leave it in whatever form they're asking. All right, so intercept form, plug in the x-intercepts, solve for a, and then just rewrite your equation at the end. Now those two are much quicker than the standard form. In standard form, first off, you have to remember what standard form is. We've used it quite a bit. Remember, standard form is y is equal to ax squared plus bx plus c. So what's going to happen is that you're going to be given 3 points, at least 3 points, and you have to take these values and basically you're going to be plugging them in for the x's and the y's and then doing substitution or elimination. And which method you use is up to you. I will typically use elimination because it's usually quicker, but if you really like substitution, you are of course welcome to do so. So I'm going to go ahead and write our steps out first. So first we're going to plug in the points into 3 equations. Okay. So I'm going to do that first. So I'm going to have, so remember these are my x's and y's each time. Okay, so xy and xy. So in my first one I'm going to have negative 3 is equal to a times negative 1 squared plus b times negative 1 and then plus c. So I'm going to go ahead and simplify that and I get negative 3 equals negative 1 squared is 1, so I get 1a, and then negative 1 times b is negative b plus c. So there's my first equation. Then I'm going to do the same thing with my second point. So I'll have negative 4 is equal to a times 0 squared plus b times 0 and then plus c. And this is nice because if I simplify this one, I get negative 4 is equal to, well, 0 times a, that all goes away. B times 0, that goes away. So I'm just left with a c. Okay, and then my last one, plug in the 6 and the 2. So I have 6 equals a times 2 squared plus b times 2 and then plus c. So simplifying that, I get 6 is equal to 4a plus 2b plus c. Now this one worked out really nicely because I got one variable already solved for. I got c was equal to negative 4. So what I can do is then plug these in to both of these equations wherever I see a c. So I'm going to use some substitution here real quick. And if you didn't have that, you'd have to do some elimination to get it down to 2 variables and then 1. So I'm going to plug these in. So now I'm going to have negative 3 is equal to a minus b and then minus 4, because that was what c was. And I'm going to add that 4 over to the other side so that I have 1 is equal to a minus b. And then I'm going to do the same thing over here with the green one. So I'll have 6 is equal to 4a plus 2b and then minus 4. Add 4 to the other side. And I'm going to get 10 is equal to 4a plus 2b. Okay, so those were canceling. So now what I have is 2 equations with 2 variables. So this is where step 2 is going to come in. Okay, so step 2 is to do elimination. So I've got 2 equations with 2 variables, so I'm going to go ahead and set these side by, or one on top of the other. So I'll have the blue one, so I'm going to have 1 equals a minus b, and then I'm going to have the green one, right below it. So 10 equals 4a plus 2b. And I just have to pick which variable I want to eliminate. So let's say I want to eliminate the b's. Well, then I need to multiply the whole top of this one by a 2. And when I do that, I get 2 equals 2a minus 2b. And then I can bring this equation over here. Nothing changed on the bottom equation. And I should have a variable that's going to cancel out. So notice my b's are going to cancel because negative 2 plus positive 2 goes away. And I'm left with 2 plus 10, that's 12. And then 2a plus 4a is 6a. And now this is a nice little equation that I can divide both sides by 6. And I get that my a is equal to 2. So now I have one of my other variables solved for. And then the very last step, of course, is to go ahead and solve for my last variable. So I'm going to take a and plug it back into one of my two equations. Maybe I plug it back into this one right here. So I'm going to say that 1 is equal to my a value minus b. So I can subtract 2 from both sides, and I get negative 1 is equal to negative b. And then, of course, divide by negative 1 on both sides. So I get b is equal to positive 1. So what I have now is I have a, I have b, and I have c, and I just used elimination. And then I have to write my final equation. So my final answer is that y is equal to, remember we're writing an equation in standard form, my a value, so 2x squared, and then plus bx, well 1 was b, so 1x, and then my c value we said was negative 4, so minus 4. So there is my final equation. So just like the others where when you write the equation you want it to be y equals something, same thing here, but you had to do a little bit of extra work to figure out what your coefficients were and then plug them back in into your final equation. All right, so really 2 steps, plug in your points into 3 different equations and then do some elimination. And you may have to do elimination more than once. This one was just a nice example where C was found right away, but if not, you're going to have to do elimination twice to get down to one variable, okay? And if you have any questions about how to do the elimination, please make sure that you ask in class and I will gladly go through those examples with you. But that's it for this section, so you should be good to go. Thanks for listening.